Okay, we are going to start we have our spectrometer, not a calorimeter, so we're going to start, and it's plugged in, and now we're going to go to Logger Pro, which is on our desktop right now, and that opens up, and at first it says no device connected, but that should change soon.
That's fine.
Alright, and there we go. And now we need to calibrate the spectrometer with our number 5. So I'll put that in the spectrometer.
And Evan, is the number 5, is it pure water, or do you have a little of something in there?
There is a little bit of the, I think it's
the iron 3?
Yes,
the
iron 3.
You're right.
Yes.
Okay, good, good.
So now from here we go to calibrate it, and that happens in the experiment section. Down to calibrate. A window pops up and you have to wait a minute and while it calibrates it. Warms it up.
And so basically we're doing an equilibrium lab. We're assuming that the SCN is the limiting one since we use the iron 3 in excess and the nitric acid. So then this means it's pushing the equilibrium to the right.
Yes.
And so then we'll actually know the equilibrium concentration of the iron thiocyanate, right?
Yes, that is correct.
Oh, that's slick. Well, good.
Oh, yes.
So, yeah, a couple more questions on this. So you're not only going to be determining the equilibrium constants for these different trials, but you're also going to be able to figure out an unknown concentration, aren't you?
Yeah, based on what we find with our given concentrations, we can use unknowns and figure out their absorptions with the spectrometer, which then we can find their unknown concentrations. So
that's
really
great.
Yeah.
Thank you. Thank you.
So now the warm-up's done.
Okay.
And now it's calibrating, which is pretty fast. And okay. Now we are going to remove number 5.
Okay.
And we are going to put in number 1, and this isn't the beginning of the actual experiment, but it's kind of the precursor.
Step like,
yeah.
step like 6
This
or
is
something?
step 6.
Okay,
yeah.
good. That's
and
good to know.
This is step B of 6.
Okay.
So putting 1 in, and now hit collect, which is a green arrow, and it should make it a graph. And now, after the graph comes up, you can press stop, and you want to store this because this is going to be the basis for the rest of your experiment. So, store latest run, and now it's stored, and then you have to change it to the
wavelength?
To absorbance versus wavelength.
Okay.
So you configure the spectrometer, and no, you need to change it from wavelength.
To absorbance.
To absorbance versus concentration.
Okay.
So press
oh,
OK.
and it looks like that absorbed at what, 442, something like that?
Yeah.
Okay.
Yep. And now you're going to leave number 1 in there, and now you're going to begin your data collecting with number 1. Okay. So you're going to press collect again, and now you're not going to press stop collecting until the very end. And that's something that a lot of kids do. They press stop in between each one, but that's not...
Follow the instructions,
That's going
right?
to create problems, yeah.
Okay.
So, and here we go.
Good point. And you know, I noticed that the iron solution is a golden color, but the maximum absorption's in the blue. And that kind of makes sense that it's absorbing the opposite of what it's reflecting, isn't it?
Mm-hmm.
So this lab really does more than equilibrium and absorbance of concentration, but now we also know the wavelength in which this iron likes to absorb.
Yeah.
Now, you told me something important about between the two cuvettes. What should the students remember? Is it okay to put another one in real quick? Or?
No, you need to wait 2 to 4 minutes, but not longer than that, to let it stabilize and get so that number will become more constant, because right now it's kind of changing.
Okay.
And,
so did you kind of watch it until you see it stabilize?
Yeah, and sometimes it won't look like, it'll keep changing, but it'll only be like between 2 or 3 numbers.
Oh, kind of like what it's doing now.
Yeah.
0.634, 0.633, 0.632.
Yeah, it's stabilizing pretty fast. So, and then, so I think this one's stable.
Okay.
So now I'm gonna press the keep button, which is right next to stop.
Okay.
And so I press keep, and then you're gonna have to put in the concentration, which is from the pre-lab exercise right here.
Oh, good. The concentrations, you wrote those down.
Yeah.
Thank you. Okay.
And so this first one is 0.0002, and just press OK.
Okay.
And after you press OK, you take out number 1, put in number 2, and the whole process starts again. And you just keep it on, and it'll start collecting the new solution.
Okay, and so I noticed that the second one looks like it's a lighter concentration. So
Yeah.
what do you expect the absorbance? The absorbance on the last one was 0.632. Do you expect this absorbance to go down then?
Yeah, this one should be a lot lower, and it should get increasingly lower as we keep going. So number 3 will be the absorption will be less than number 2, and so on.
So do you think it's accurate to say that the absorption is opposite of the transmittance?
Yes.
Okay.
Yes, that is.
Okay, so that means that the least concentrated one has the most light going through it, and the most concentrated one has the least light going through it.
Yes, that's
Okay,
correct.
so that fits with what we said about the absorption being higher for a more concentrated solution. Okay. Now, can I notice that when we were looking at these, we can kind of eyeball the unknown too, and kind of do a guess where we expect it might be, but we can't get an exact number unless you use this SpectroViz, right?
Yeah, because you can tell that an unknown is between 2 colors, but you can't see it. Oh, it's exactly halfway between these 2. You can't be that exact just with eyeballing it. So you can do the physical test on it and get that exact number.
So if you're going to be a scientist, you want to use something like this.
Yes.
If you're playing horseshoes, then it's okay to speculate.
Yeah.
Okay.
Exactly.
Okay.
Okay, so this one looks stable. So we're going to keep this value. Put in the concentration, which is 0.00016. Press OK. And trade it out again. And every time you press the keep and you put in the concentration, it makes a list of your absorption values and the concentration and the wavelength.
Oh, I see. And here's that taskbar that you were talking about.
Yeah.
The far right, that wheel on the far right is known as the
Keep button.
keep button. The one on the red is your collect and stop button, isn't
Yes.
it? Okay. And then we'll be looking at some of these graphs in a moment to see the linear fit one. Okay. So this one looks like it's still trying to stabilize, 0.353. It's been there for a while.
I think that's good.
Okay, sounds good.
All right, keeping that
So
one.
don't forget to hit keep current. Good. And then we're going to put in the concentration for that one.
Which is 0.00012.
Okay, 0.00012, and that's from the pre-lab exercise that we've calculated these. Good. Okay, so we're putting number 4 in, and we're making sure that we're putting the clear side of the cuvette where the light passes through. The ridges should be opposite. And if you get fingerprints on there, why could that mess up your result?